Hi everyone, welcome to
Hey guys.
lesson 3. So today we're going to talk about what are the relationships between central and inscribed angles. So for today we're going to have a mini lesson, which is now. You're going to have an exit slip just like you had before. So it's going to be it's going to be a Google form, but we're going to give you until Wednesday midnight. So you have a lot of time to complete it, and that's going to be graded. And then your homework, which we posted, is going to be due next Tuesday. And that homework is going to be a mix between the lessons that you did last week. Yeah, the first 4 lessons, which is the lessons from last week, and the lessons from this week. Okay? So before we do anything, we're going to do a recap of the first 2 lessons.
Okay. All right. So in the first few lessons, the first thing that we did was talk to you guys about circles. What is a circle? That's what this whole unit is about. So what we told you first was that when you name a circle, you start by calling it by its center. So the center of the circle is O. So that means that this circle's name is O, right? And we said a circle is just a set of all points that's equidistant from that center. So all points equidistant from that center O is your circle. And then we started to teach you guys about parts of a circle. So one part that we taught you guys about was called the radius. The radius is just a point that goes from the center to another part on the circumference of the circle, right? So for example, you have OB, that's your radius. Then we taught you guys about chords. Chords are similar to radii, right? Chords go from one part of the circle's circumference to another. The only difference is that they don't go through the center. So an example of a chord would be ED. And then we taught you guys about the other special piece that you've probably heard a million times before, the diameter. So the diameter goes from one end of the circle to the other, and it passes through the center, and it's twice the length of the radius. So in this case, the diameter would be AC. So those were the main things that we taught you guys about parts of the circle. Then we taught you guys about something called arcs. So we taught you about major arcs and minor arcs. So we know that a whole circle is 360 degrees, but arcs are pieces of the circle or parts of that circle's circumference, right? So if the whole circle is 360 degrees, half of a circle is 180 degrees. So we told you that a major arc is a little bit more than 180 degrees. So for example, 180 degrees on this circle would be from A to B to C, right? That's 180 degrees, that's half of the circle. But we said a major arc is a little bit more than half of that. So a major arc would go, for example, from A to B all the way to D. And then
like more than half.
You guys, right, just a little bit more than half. Then we taught you guys about minor arcs. Minor arcs go a little less than half of the circle. So an example of a minor arc would be from A to B. The last 2 things that we taught you in the previous lesson was what a central arc was. So, central angle, mistake number 1. What a central angle was. All right, so central angles are angles that come from the vertex. The vertex is the center of the circle. So we said the center of the circle is O, right? So an angle that comes from the center would be a central angle. So this is the time where I'm actually going to call on somebody. And you can just unmute yourself to answer. Can you give me an example of a central angle in this picture?
You can just unmute yourself or type in the chat if you want. What's an example of a central angle in this picture? Remember, here's a hint. A central angle is where the vertex of the angle, right, where the 2 rays meet, is in the center of the angle. Or sorry, the center of the circle. So what's an angle? Yeah.
Angle BOC.
BOC. That's perfect. Angle BOC. And as you notice, the angle when you name it, O has to be in the middle because that's a central angle.
Mhm.
Perfect, Adam. And the second central angle is angle AOB. Awesome.
Perfect. Okay.
All right.
And then can we also talk about one of the properties of central angles too?
So the very last thing that we taught you guys was when you have central angles, there's a special property that goes with it. So central angles, the measure of the central angle is the exact same measure of the arc. So for example, if we told you the measure of angle AOB was 40, so if we told you that was 40.
Yeah, so this angle is 40 degrees.
What else should you be able to tell us? So what other piece of information? Remember, once again, we said that the measure of the central angle is the same thing as the arc that it intercepts.
So if this angle is 40 degrees, what could you tell us about arc AB? What's the measure of arc AB?
Isn't it also 40 degrees?
Perfect.
Yeah, perfect.
Right?
Then the measure of arc AB is 40 degrees too. Central angles are when the central angle is equal to the arc. They're equal to each other. Okay. All right. So we're gonna move on. So that was like a quick review of like the last two lessons. Okay. Parts of circles and also what a central angle is. Now we're gonna talk about something else. And this is called an inscribed angle. An inscribed angle is one whose vertex lies on the circle and whose rays both intersect the circle. So there's something I want to point out. Number one, when we say on the circle, this means on the circumference. On the circumference of the circle. Okay. Quick thing. What's the difference between an inscribed angle, which is what you see in front of yourself right now, versus a central angle? You can unmute or type. What's the difference between an inscribed angle, which is what you see in front of yourself right now, versus a central angle? What do you notice? What's the difference? Just by looking at it. And how about this?
Can you go back for one? Yeah, I was gonna say.
I'm gonna make
side
one,
by
yeah.
side. Perfect.
Yeah. So let's pretend this is the center. Okay. So for example, let's do this in green because it's the best color. This is going to show a central angle. So let's say that's D, that's J, and that's F. And this is going to depict an inscribed angle. Can someone explain what the visual difference is between an inscribed angle and a central angle? So two people, the central angle's vertex is in the middle of the circle while the inscribed vertex is on the circumference. The vertex for the central angle is connecting with the center. Yeah, so you're both saying the same thing. So inscribed angle, the angles where the rays meet the vertex is on the circumference. And for central angle, the vertex is in the center of the circle. That's the visual difference between both of these things. Okay, so just
a quick reminder too that central angle has that word center in it. So that's just one way that you could help think about it.
Yes. So, so just like central angles had a property where the angle of a central angle equaled the measure of the arc, there is going to be a different property with inscribed angles, which is what we're going to talk about in just a second. But before we get there, what's so important, especially with circles, because we're going to learn a lot of facts about circles, is you need to be able to identify like inscribed angles and central angles and all these different things by looking at a picture. So before we even talk about the math, we want to go over like just by looking at it, like can we identify? That's what we're going to do next.
Okay. Actually, can you go back for 1 second, Mr. D'Souza?
Sure.
So just one more thing to point out about inscribed angles, or central angles in general. We always talk about the arc that it intercepts. That's one way that you can quickly identify it. So for example, this angle, the inscribed angle NAD, right, it's intercepting the arc ND. And the way that you know that is if you look at, it kind of forms this V shape, right? If you look at the 2 points that lie on that V, that lie on the circle, the N and the D, that's where they lie. So that's the arc that it intercepts. So the
kind of
same
like a pizza slice, it's the crust.
Right. Yeah. And for the central angle, the 2 points, like the J and the 2 points are on the J and the F. So this angle D intercepts arc JF. So this is important to know. You're going to see that more in a second.
So actually, I kind of like that with like the whole pizza thing, right? So if you're thinking of like central angles and inscribed angles as like slices of pizza, the crust is the intercepted arc. That's cool. I just thought about that. So yeah, so if you think about like the crust of the pizza is the intercepted arc. Very cool. Okay, so now let's talk about like how can we identify inscribed angles?
All right. So what I want you guys to do, either in the comments or you can unmute yourself, can you just name all of the inscribed angles that you see in the picture? Or you could just name one at a time if you want. Okay, so someone said angle DAB. Perfect. Isaiah said, so you're gonna highlight it?
Yep, I got
Perfect.
it. I'm just gonna move up the picture so that we can see. So I'm sorry, what was the first one?
So the first one was angle DAB, like dab. The second one was angle ADC. Then we have angle C, well, CDA is gonna highlight that same angle.
CDA, we haven't said that yet.
No, sorry, CDA.
Nope. CDA.
And we're missing something. You guys named a lot of, almost everything, but we're still missing something. One.
So can I give a hint? So remember, when we name angles, the middle letter is the vertex of the angle. And we know if we're trying to name inscribed angles, yeah, thank you, we're gonna get to that. So that means one of them the middle letter has to be A, one of the middle letters has to be D, one of the middle letters has to be B. And just as Zarif just pointed out, the last one has to have a middle letter of C. So DCA is the last one.
Perfect.
Awesome.
All right. So a second question to follow up with is, can two inscribed angles intercept, or the mathematical word for it is subtend? So can two inscribed angles intercept the same arc? So remember, we told you when angles intercept the same arc, look for that crust of the pizza. Where the V lands, that crust area is where they're intercepting. So is that possible? And if you think it's possible, give us an example from this picture.
Yeah. So if you were to trace the two inscribed angles, can they both share an arc? Meaning, can they both share like a pizza crust?
What if we highlight a couple of them?
Sure. So let's highlight DB. Sorry, my hands are so shaky. DBA. So do you see, for this inscribed angle, it intercepts or subtends this arc. right? Do you see if I just outline that, you see how it intercepts that arc? Is there another inscribed angle that also intersects that arc? So Zav is saying yes. Who else do we think? Do we all agree? Do we disagree? Javier says yes. Hi, welcome Javier. What's up, man? So if you're saying yes, so I see a lot of people saying yes. So if it's yes, what's the other angle? I'll do it in the best color, which is green. So can someone name another inscribed angle that also intersects that yellow arc? DCA. Let me
nice.
So check this out. DCA. I should be using straight lines. Do you see, now that we highlighted it, that these two inscribed angles intercept, meaning like their pizza crust? So if this green thing was a pizza, this is its crust. If this red thing was a pizza, this is its crust. Do you see how they both use the same intersected arc? I need to see either yeses. I need either people to say yes or no.
You can do a thumbs up, or on your reactions, you can say yes. If you're not sure and you don't see it, you can say no.
I need to see at least 4 people participate. So I got a yes from Vanessa. Randy, I got a yes. Arjun, I got a yes. I need one more. One more. Okay. So yeah. So we haven't.
Oh, hey, Dom. Dom's here.
What's up, Dom? We haven't talked about like mathematical relationships yet, but knowing what we know about central angles and them having relationships. I'm sorry, I'm taking this away from Miss James. Go for it.
It's all right. So what do you guys think that could mean? So these two angles are these two inscribed angles are intercepting the same arc. So what do you think that means about those two angles? What could that possibly mean?
I think
you can either unmute yourself or say it in the comments.
Again, this is just a guess. We don't have an answer yet. We're gonna get there. Take a risk. You can type it out. Are they similar? So that's actually super, super interesting that we're gonna get to much later about triangles and circles and similarities. But we're not there yet. But I love what you're thinking about.
I love that too. Very cool.
Yeah,
thanks, Vanessa.
I really don't.
But maybe along those lines.
Could they have the same angle measure?
So something that you might be thinking is if they intersect the same arc, and the way that we relate angles and circles with their intercepted arcs is if they have the same arc, maybe they have the same angle. Maybe. We're about to find out. But before we get there, we need to go back in time. It's Tuesday, right? So we're going to do Throwback Tuesday.
All right. A blast from the past. Take you all the way back to like September, October. When we taught you guys about the exterior angle theorem. Does somebody remember the exterior angle theorem and you're brave enough to share what it is? A lot of you guys did your projects on this. So,
and if you're wrong,
somebody
okay.
brave enough.
Or can you describe what it is?
It doesn't have to be perfect. We'll help you. So an interior plus an interior equals the exterior. That's pretty much it, but we'll get more specific. So I'll show you, we'll have this diagram for you. So the exterior angle theorem says that the measure of an exterior angle, that means like the angle on the outside. So in this diagram, angle ACD, or angle 3 is the exterior angle, right? The measure of an exterior angle of a triangle is equal to the sum of the two remote interior angles. By remote interior, another word for that is non-adjacent. So angles 1 and 2, when you add them together, the value or the sum is going to give you angle 3.
Okay. So this is going to be super important. You might be like, Mr. D'Souza, Miss James, why are we talking about exterior angle theorem if we're talking about circles? they incredibly relate, and it's actually really, really, really dope. So just keep that in mind. Exterior angle theorem, you add the two non-adjacent angles to the exterior angle, and it equals that angle. All right, just remember this picture. Look at it. Take a little image in your head.
All right. Mental screenshot.
All right, so this is what I need you to do. Okay, I'm gonna give you just a couple of seconds to just copy down the picture on the right. You can copy the other stuff down a little bit later, but all I want you to do is copy the picture on the right. I'll give you about like 10 seconds. Okay. About 10 seconds. All right.
While you guys are copying it, I'll read the question to buy you some more time, because 10 seconds is not enough, Mr. This is a mistake.
All right. Okay.
In the diagram of circle M, AC is a diameter. We wish to show that the measure of angle BAC is half the measure of arc BC.
Okay. So case in point, what we're going to prove for you, without doing like the 2-column proof, we're going to prove to you that the measure of the inscribed angle is going to be half the measure of the arc. Okay, and we're going to show you using stuff that you know or that you've seen before. Okay, so this is really where you're going to be writing down a lot of stuff. But in order for us to get there, we got to look at things that we already know. Okay, so the first question that we have for you is, can someone either type out or just talk? Why is triangle BMA, so BMA, oops, why is that triangle that I outlined in green an isosceles triangle? I want you to think back to, I believe, lesson 2.
It's because BM and MA are both radii, so they have the same value.
Yes, thank you so much. So the radii of a circle are all the same. So that means their lengths are the same. So that means that we know that BM and AM are congruent. And when in a triangle, when at least 2 sides are congruent, then it's an isosceles triangle. Now you might be asking yourself, why do I need to know this? Well, what do we now know about angles 1 and angle 2? Can anyone call out or type in, what do we know about angles 1 and angle 2 now that this triangle is an isosceles triangle? Excuse me.
Angle 1 and 2 are congruent.
Yes. So you know what? I'm going to start writing down some of this information. So, excuse me. So we got angle 1 is congruent to angle 2. In an isosceles triangle, the angles that are opposite the congruent sides, so that would be angle 1 and 2, are congruent. Okay? That's a little blast from the past. All right. So what we're going to do now is I'm going to write down a list of things that we know just by looking at this picture. Okay? So things that we can assume just by the information that's given for us. Okay? So the first thing that I want to talk about is, what do we know about angle 3? Do we know what that is equal to? Or actually, let's take a step back. What type of angle is angle 3? You can type it out or you can call out. What type of angle is angle 3? That's this angle. You can actually say there's 2 answers for this. So it's definitely an exterior angle, and we're going to use that in just a little bit. But using new knowledge that you learned last Thursday, what other name could you also give this? It's also a central angle. So you see how the angle is created where the vertex is at the center. All right. So if that's a central angle, what is this angle equal to? The measure of, I need someone to say it. The central angle is equal to the measure of what?
What did you guys learn about central angles last week?
The measure of arc BC. So it's equal to the measure of arc BC. Okay, that's fact number 1. Just by looking at this picture, you know that's a central angle. Central angles are equal to the measure of its intercepted arc. That's number 1. Number 2, since we know that this triangle is isosceles, we know that angle 1 is equal to angle 2. Okay, that's something else that we already talked about. And the last thing that we need that's going to put all this wonderful stuff together is ignore the circle. What do you see? Ignore the circumference of the circle. What do you see? What do you see? What shapes do you see? Does it relate to something that we were just looking
Javier.
at?
Javier said he sees a triangle.
You see a triangle, and then going off of what Zarif was saying is that there's an exterior angle. So can someone tell us a relationship between all of those angles, angles 1, 2, and 3? Angle
Nice.
1 plus angle 2 is angle 3. I'm going to applaud you for that. Thank you, thank you.
Perfect.
Okay, so I'm going to write that down here. That angle 1 plus angle 2 is equal to angle 3. Okay. Now what we're going to do is I'm going to prove to you the relationship between inscribed angles and their intercepted arc. Okay. So again, you're more than welcome to unmute yourself and be like, stop, I have a question. That's totally cool. Okay. Let's choose a different color. Let's do like an orangey type color, because why not? All right. So the first thing I'm going to write, the first thing that we know for sure is that the measure of angle 1 plus the measure of angle 2 is equal to angle 3. All right. I'm using that fact. If you want to get technical, that's a given. Okay? All right. So just by looking at this equation, we also know something else. All of you said, hey, isn't angle 1 the same thing as angle 2? I'm going to assume that you're saying yes. Okay. So couldn't I replace angle 2 with angle 1 because they're the same thing? That means I could rewrite it like this. Angle 1 plus, well, I know angle 2 is the same value as angle 1. So I'm going to replace angle 2 with angle 1. And that still equals angle 3. Can I just see a thumbs up or a smiley face if you're following so far? Or if you have a question, can you ask a question? Okay, I see a smiley face. Cool. I need to see, yes. Sick. Okay, cool. So check this out. I'm gonna do this in a different color. Okay, we're gonna step away from the proof. I'm gonna ask you a question. If I have x plus x equals, let's say 3, how do you simplify? How could we combine like terms? What's x plus x? Yeah, someone said it, Zarif said it, right? X, a variable plus a variable is 2 times that, right? So if I have 1 apple plus another apple, those are 2 apples, right? So similarly, let me switch back to my color, just so we're all the same. Similarly, if I have angle 1 plus angle 1, that's the same thing as saying 2 times angle 1 equals angle 3. Okay? Now, I want you to check something out, because I really want you to understand why we're doing this. I want to come up, or rather, we want to come up with some kind of relationship that talks about our inscribed angle. And to remind you, the inscribed angle in this picture is BAC, which happens to be angle 1. So if I solve for angle 1, it's going to tell me a relationship. Okay? So can someone tell us what's the next step that I can do to get angle 1 by itself if I was solving for angle 1? And you can unmute yourself and talk, or you can type it out.
Divide by 2. Divide angle 3 by
2. Yeah, divide by 2. Boom. Inverse operations. And we get angle 1 is equal to, now, when we divide something by 2, isn't that just half of it, halving it? Yeah, right?
We need a couple of yeses.
Yeah. So dividing by 2 is the same thing as multiplying by a half, right? So I can say that angle 1 is the same thing as 1/2 of angle 3, right? So do you notice that we used this fact? We used this fact. We still haven't used this last fact that we were able to assume. So we're going to do one more thing. Let's choose purple. No, let's use dark blue. All right. So we got angle 1 is equal to half of angle 3. Oops. Mistake.
That's a mistake.
Is half of angle 3. So what do we know that angle 3 is equal to? Yes, I know, Javier, it's a mistake. But what do we know that angle 3 is equal to? What did we just say? Angle 3 is equal to what? What's the last thing that we have not used yet? Yeah, it's equal to the measure of arc BC. So now we just solved for angle 1. We actually just derived a very, very important fact about inscribed angles. Okay, so I'm going to type it out just because I think it's going to be a lot neater if I type it out. Inscribed angles.
This is important. If you guys want to take a second and write this down, this is the important property about inscribed angles.
Okay, inscribed angles are equal to half of the intercepted arc. Oops. Okay. So I rather what we just did. Whoops. What we just did is we proved it. We proved that if I give you, we're going to go over many examples, not many, we're going to go over a few examples, but if I give you the measure of this angle, the angle is always going to be half the measure of the arc that it intercepts, which is what we have right here, that angle 1 is half the measure of arc BC. This is a proof of that. Okay. Does anyone have any questions or comments or anything that they want to say about this?
So we said that the intercepted arc is if you trace out the angle, right? So like it makes this V shape.
I'll do it here again.
When you trace out the angle, the inscribed angle, right? You see the V shape?
Oh, I got it for 1 second. 1 second. So when you trace the angle, yeah.
So it makes a V shape, and where the 2 points on that V touch the arc, or you could think of it as a crest, that's the intercepted arc. So can you highlight that?
So you see the ends of the V. It's kind of like a pizza. So like this is like the pizza, and the yellow is like the crust. The crust is essentially the intercepted arc. Did that answer your question, Gareth? Okay. Anyone else have any other questions or comments about this? And then we're gonna do a couple examples. Okay. All right, so we're gonna move on. So now we're going to do what does this look like? So if we give you some just some quick examples of like what we could ask you, that's what we're going to do right now. So if you just got in, because I see a lot of you, some of you are just coming in now, maybe some of you are behind me writing some notes down. This thing that's in the top left box, that's what you should have in your notes. An inscribed angle is one whose vertex lies on the circle and whose rays both intersect the circle. And now we know that the property is that the measure of the inscribed angle is half the measure of the intercepted arc. Okay? So central angles are equal. Well, central angles are equal. And inscribed angles are half. All right.
Okay, so with that in mind, we have 2 examples. The first thing, before we even get to the examples, I'm just going to ask you guys questions that might seem intuitive now, but it's going to be important for later. So the first thing that I want to do in question 1, is this a central angle or an inscribed angle? And how do you know?
So you can either call out or you can type out, is this a central angle or is this an inscribed angle, and why?
Inscribed angle.
Why?
Because, how can I describe this?
So Zaf saying inscribed since the vertex isn't touching the center. So, but let me ask you a question. I'm gonna oops, let me do it in a different color. If I draw this, which is also an angle, that's an angle that doesn't touch the center, but that's not an inscribed angle. So how can you be more specific on what or why that's an inscribed angle?
Its vertex is on it's on the circle.
The vertex lies on the circle. Perfect. All right, so this is an inscribed angle. Now that we know that, what property did we just learn about inscribed angles?
It's right here. You can read that. Or type it out.
What did we just learn? What was the key thing?
The inscribed angle is blank, the measure of its intercepted arc. What do we know?
It's
Half.
Thank you, guys. Thank you. So if the inscribed angle is half of the intercepted arc, what's the intercepted arc? So the angle that we're looking for is angle A. What's the intercepted arc here?
What's the name of it? You can just type it out. What's the name of the arc? That's the intercepted arc. Oh, so Dom said it, BC.
Perfect, thank
you.
you guys. So angle A has to be half of whatever BC is. And some of you guys are thinking, I could just do this in my head, right? At this point, but we're gonna just go through it step by step. All right, so angle A is half of BC. So what's BC? What's arc BC?
What's the measure? 80.
Perfect, so arc BC is 80 degrees. So angle A has to be half of 80. So what's half of 80, somebody?
Boom.
40.
So the measure of angle A is 40. We're done? Is this the final answer? Is this the final
Is
answer?
everything okay with this answer? Would you get full credit for this in the region? Are we missing anything?
Is this a yes right now? Degrees, yes, it has to have degrees. Thank you, I appreciate it. Thank you. All right, next one.
All right, the second question is kind of the reverse. So they gave us the angle, and now they want us to find the intercepted arc, or the measure of that arc, right? So we know that the relationship between actually, what type of angle is this? I'm sorry. Is this inscribed or central, and how do you know?
So we're talking about this arc, we're going to be using this angle. So is angle X a central angle, or is it an inscribed angle? So before we get to the answer,
we just want to talk about what type of angle it is.
Is it central or inscribed? So remember, central angles are angles where the vertex, so this is the vertex of the angle, starts in the center. But Zarif is saying it's inscribed. It is inscribed because the vertex, meaning where the two angles meet, are on the circle. And we know that inscribed angles are half the measure of its intercepted arc.
So the intercepted arc is WV. So angle X has to be half of WV. So we know the measure of angle X. What is the measure of angle X? Somebody type it out for us. Or call it out. What's the measure of angle X?
42.
42. Thank you, Isaiah. So 42 is half of WV. So if we're trying to figure out what WV is, we said earlier, half of some, like if you're trying half of something, or like, how would you get WV by itself? What would you do?
What's the opposite of halving something?
Yeah.
Yeah, you double it.
Multiply by 2, right?
Both sides by 2. Times 2. Times 2. What's 42?
So what's 42 times 2?
84. Boom. 84 degrees equals the measure of arc WV. Okay. Make sure you have that written down.
I will color the table yet. Mommy, I thought we put
All right.
color.
So there's one more question we want to ask. Ms. Seamus, do you want to ask it?
With the pencil.
Yeah.
I mean,
So, what is the measure of angle W, and how do you know?
Why? So we're going to ask an extension question. Yeah, go for it. What's the measure of angle W and how do you know? So I see one person saying 96 degrees. What else do we think?
You can take a guess.
So
what's the measure of angle W?
So Zarif, you're assuming that XWV is an isosceles triangle. Do you have enough information to know that? Do we tell you it's isosceles, or are two of the sides radii? Yeah. So I'm going to give you a hint, right? I'm going to outline angle W to the best of my ability.
If you had to guess, what type of angle would that be?
Is it central or
L
inscribed?
shape. Oh, I'm sorry.
Oh, I see what you're saying. Yeah, I see what you're saying.
If you had to take a guess, what type of angle would that be? Or
If
what
you
would
had
be
to
the
assume.
measure of that?
Okay, so Zarif says 90. What does everyone else think?
It's working on
You had to take a wild guess. Okay, so some people are saying 90 degrees.
You can't hear me
Isn't
anymore.
XV, what line is XV? What part of the circle is XV?
Dad can't hear me, Mommy.
Everyone can hear you, sweetie.
Dad can hear me.
So XV, what part of the circle is that? Remember we talked
What's
in the
it called
very beginning.
It goes from one end of the circle to the other.
So one end of the circle to the
and
other.
it passes through the center. What type of line is
What is
that?
that line called? Yeah.
A diameter.
That's a diameter. And a diameter is half of a circle, right? So if a full circle is 360 degrees, what's half of that?
Dad.
Stop it.
180 degrees. All right. So half the circle is 180 degrees. So when you find an inscribed angle of the diameter, that's going to be 180 degrees. All right. That's just a little quick thing. You gotta be very, very, very careful. All right. All right. So we're going to move on to what this is going to look like on the regions. We're almost there. I really appreciate for those who stayed. Oh, you want to go back? Sure. No problem. I'll erase it. I'll do it one more time. So, boom. Boom, boom, boom. Okay. That's totally fine. I appreciate you guys asking. So, usually when we talk about angles and circles, the best thing to do is highlight the angle. So I'm going to highlight angle X, W, V. Okay. First thing that we all said was that the highlighted angle is an inscribed angle because the vertex of the angle is on the center, is on the circumference of the circle, right? So that means we know that the measure of angle W is going to be half the measure of arc XV. Okay. All right. But going back, we know a full circle is 360 degrees. So we just identified that line segment XV is a diameter, and a diameter cuts a circle in half. So how many degrees are in half of a circle? Can someone type it out? How many degrees are in half of a circle? 180. So the measure of angle W is equal to half of 180 degrees. And what's half of 180? Because remember, this is an inscribed angle. Half of 180 is 90. So now we know that angle W is 90 degrees. Can I get a smiley face or something that tells me that you got it now? Or if you have another question, you're more than welcome to ask. You're very welcome. Cool. Awesome. So we're going to be moving on. So now we want to show you what this is going to look like on the region. This is literally taken from the region. The question says, in the diagram below of circle O, line segment OB and OC are radii, and chords AB, BC, and AC are drawn. If angle O is 60 degrees, determine the measure of angle A. So before you do anything, I know this looks like a crazy picture. What should you always do in addition to reading the problem first? This is perfect timing too. What should you always do? Annotate, yes. So what could I do? It's the only thing I can do right now. What can I write on this picture? Yeah, mark up your diagram. So what we got so far is that angle O is 60 degrees. So I know that this angle is 60 degrees. And I'm trying to figure out the measure of angle A. And angle A is this one. Okay. So is there anything that we know in relationship to the angle O, which is angle 60? I'll highlight it for you. Do we know anything about this angle? Wait for someone to respond. Yeah, it's a central angle. So what do we know about central angles and its intercepted arc? A little throwback. Central angles and their intercepted arcs. Yeah, they're equal. So that means, I'm going to do this in a different color, that this arc, its measure is 60 degrees too. I would like for someone to now explain how that helps us find angle A now. And I want to hear from someone else I have not heard from. So now that we know that arc BC is 60 degrees, how does that help us determine what angle A is? So remember, we want to find the measure of angle A. How does that help us? So ABC is an inscribed angle, yes. So the angle is half the measure of the arc. So yes, let's write that out. So the measure of angle A is 1/2 the measure of the intercepted arc BC. Let's write in what we know. Well, we don't know angle A yet, but we know what BC is now. So what's BC? 60. So if I ask you, hey, what's half of 60? What's half of 60, guys?
Don't get it when I do.
Half of 60 is 30. And that's it. The measure of angle A is 30 degrees. Okay. Does anyone have any questions about how we did this problem or need us to go over it one more time? Because then we're going to summarize. Anyone else? I'll give you some time. Awesome. Okay. So we're just going to summarize. Oh no, we're going to do one more check for understanding. I forgot we have this. So do this on your own. If angle L is 40 degrees, I would like for you to determine the measure of arc DLJ. Please don't write your answer yet. I'll let you know when to type out your answer. But I really want everyone to try this on your own first. So what we want you to get out of today is if we give you an inscribed angle, can you determine either the arc or the angle? Okay, so take some time, do it on your own. And then I'll let you know when to type it in. Excuse me. All right, so type out your answers. If angle L is 40 degrees, determine the measure of arc DLJ. So I see some people say 280. Okay, so let's go over it. So if angle L is 40 degrees, let me do this in a different color. If this is 40 degrees, okay? And we want to find DLJ, right? Let's highlight DLJ. So here's D to L to J. It's this huge major arc. This is what they love to do on the regions, okay? So if we know that this angle is 40 degrees, what's the only other piece of information that you can find just with 40 degrees? So if the measure of angle L is 40 degrees, then what else do we know? We know arc DJ. So arc DJ is equal to what? Remember, angle L is inscribed, so it must be half the measure of the arc. So if 40 is half the measure of this arc, DJ must be double. So 40 times 2 is 80. And a lot of you probably got this answer first.
Disagree.
Remember, 80 degrees represents this. It's the pizza slice. But is that what the question's asking you to do? No, it's trying to ask you for this highlighted piece. So what do we know about a full circle? A full circle adds up to what? The angle measurement of a full circle adds up to what? 360, right? I want this yellow piece. So if I know this red piece, how can I get rid of the red piece so I have what's remaining? What can I mathematically do to get my remaining piece that's yellow? Subtract. So 360, the full circle, taking away 80, that's our red piece. So the full circle, taking away the red piece, lets us have the remaining piece, which is what we said, 280. This is 280. Am I done? If I write this, will
Would
that
you
give
get
me
full credit for this?
Yes, degrees, yes. So if I write 280 degrees, am I done? No, Vanessa and Javier say no. Why no? Make me proud, please. What are we missing? That gives you full credit. So we already have
the
degrees.
now. Yes,
Measure
so
of arc
Measure,
DLJ.
yes. So the measure of arc DLJ is 280 degrees. Because you got to answer the question that they're asking you to answer. Yes, you got to put the arc, yes. So if they ask you, like, determine this, your answer must be that. They're very particular with how you answer your questions. So that kind of wraps up. Awesome, that makes me very happy, Isaiah. So that wraps up the mini lesson portion. Since you're not going to have math work tomorrow, I'm just letting you know we're going to be posting this as a video, and we're going to be posting practice problems for you to work on in a little bit. So thank you so much. I'm going to stop recording, and then we can just talk and you can ask questions if you want. All right? Thank you, guys.